Hi, my name's Gary Taylor, and we're talking mass transit. I'm going to focus this session on the mediator and just try to get to grips with what it is and how it works and how it differs from anything else in the tech stack that exists here. So over at the mediator page, we can see mass transit includes a mediator implementation with full support for consumer handling and sagas. Let's have a look at the design pattern. So let's head out to here. So there's lots of design patterns. If you get used to software engineering, you'll find, 21 principles of design patterns, and um, these things are designed so that common problems can be solved in a common way. So as you're a developer, you don't have to learn a different way of solving problems. You can generally solve most complex problems these days using a mixture of these known design patterns. The problem is that they're not easily memorized, and they all kind of fit into the same kind of idea. You have to be quite good at memorizing and coming up with it. And generally, what I find is people just research it when they see a need. So we've got a mediator pattern, and it's designed to encapsulate complexity away from an object. Like an interface, you can use an interface so that you can hide the complexity and reuse it somewhere else. A mediator pattern does the same thing. So we can see here where you have a mediator class that underneath actually uses these two components. These are using interfaces as well, so they could always be swapped out whenever. And we're able to call a method like change state, and we run underlining um, features or classes based off that, which means we can mediate or delegate all responsibilities to how we change state within our application, and we can do it here. And the developer doesn't need to care how, as long as he uses this mediator class, we're okay. Uh, that, in my opinion, fits with the whole mass transit messaging bus type system anyway. It's kind of what it's all about, is encapsulating and allowing you to have separation of concerns. So let's give this a go, should we? Let's try and fire this up. So I'm going to copy you, head over to code, not now. So let's open my terminal, let's create a new project. So .NET new, uh, what's this going to be? Did they give us any clues as to what to run it as? Nope. Okay. I'm just trying to work out what type of project to create. So, got a consumer program. This looks like just a console app to me. Okay, let's do that then. .NET console, I think. And I want this to be called MassTransit Mediator. I think that's good enough. Once that's built, let's dive into that. Change directory to MassTransit Mediator. And if we do code R, it'll open up code but keep this window. However, it kind of closes terminals and everything, which is a bit annoying. Okay, so we've got a new project. .NET build. Come on, fat fingers. Just change my keyboard out. Yeah, I want all the stuff to allow it to compile because that's useful. To be able to IntelliSense, that's also useful. Okay, so let's head out to this. Let's go straight to the top. So configuring a mediator is similar to a bus. We've done that a couple of times now as we've gone through those other examples. So in the task, in main rather, we can just create that. Oops. new system, by the way, so it's not me being daft. I do know it's copy and paste. So program should have a main method. Yep. So mediator creates a new bus and create a mediator, and then we configure a consumer, and it's a submit orders consumer. So obviously mediator doesn't exist yet. Normally they give us some little helpers at the top that says what kind of thing we want to include. File, open recent files. I just want to get my README. So I'm going to stick with 178. That's 718 rather. There's MassTransit. Let's get that installed. So nothing yet. And basically, obviously I did need to include it as well. Hey dear. Fat fingers again. So the bus has gone away, but the mediator is obviously not part of the standard MassTransit package. It's part of something else. Mediator helps if I look at the example. So I don't think that's obviously going to be part of the existing. Oh, it is. It's part of the MassTransit UGet package. Right, submit order is obviously not going to be there because we've not made that consumer yet. And I think that this is going to be in memory. Yeah, runs in memory. So there's no transport, there's nothing. In fact, it even uses pointer references between messages, so it's lightning quick. So one of the things I noticed in a couple of other videos was I kind of moaned a lot about, well, this isn't real, this is not the way it should be, blah, 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 blah. But with everything, as you learn more, you get a better understanding. And the typical idea is that if you start off with this design pattern in a monolithic application, you can then separate it out over time. Where if you've designed it that way, you can have the power of a monolithic app. In other words, easy to build, easy to maintain, easy to develop and design, and you're not constrained by any architectural design principles you've put in. You can just actually write code and solve a problem. And once you know the problem, then it's easy to refactor. But if you've used this mediator pattern, and if you've used MassTransit's ability to do it in memory, and you've got consumers and producers passing messages, then actually you can take any of these consumers out and then start using whatever transport layer you want. For me, it's RabbitMQ that I'm focusing on. But obviously, you could use Kafka if you're a multi-billion-pound bank, or or any other like queuing system that fits your organization. So we need some kind of contracts, I think. Once created, a mediator doesn't need to start or stop because it's used immediately. iMediator combines several other interfaces into a single interface, including things like the publisher that we get, like the iSend and iPublish, and a client factory. So it bundles all of that together under one easy to use system. What do we say? There is a difference between sending and publishing. I don't really care, but there obviously is. Send expects a message to be consumed, and publish, on the other hand, does not require the message to be consumed. I think it's related, and we'll know more about this as we go along. If you send something, you're wanting an action to be done, like take £10 off their bank balance, complete this order. Where a publish can be used for events like um, uh, um, item bought, and one is buying item, and that's the process of actually doing it, taking the money out, taking it out of stock, and then you publish a message to say, yeah, it's been done, and that's a common way to split between send and publish. But we'll know more as we go along. Consumers can be connected and disconnected from mediators at runtime, allowing for components and services to temporarily consume messages. So that's pretty cool. We can actually disconnect and connect during runtime. So we've got consume there. We've got something like this, which could actually be used to do this programmatically, like that, which we probably won't do yet. Then to send a request using a mediator, we need a client, which is an instance of a class that implements the iMediator. The example below configures two consumers and then sends a submit order followed by a get order status request. Cool. Okay. So submit orders, order status. So create a GUID, we send it just using a mediator. So this is the pattern for creating that mediator. So actually we already knew that. Bit thick. New keyboard. Right. Let's copy and paste this. Let's put you in here. So order status consumer. Okay, so here we're going into the consumer world. Got an interface, which would be our contract. It's just an order ID. Another interface, which is our order status, which has the order and a status. So let's copy them puppies there. So get order status. So let's include tasks. Tasks, is it? Threads. There we go. So that should solve that problem. Yep. So that looks good. We've also got a submit. So we've got the order status done. So we need the submit orders. And here we've got a consumer that's just going to consume that message. It's going to hopefully subscribe to that get orders. Might need to set that up, but maybe not because it's all handled through this mediator. And we'll get this message and we're just going to process it. So we're asynchronous, exceptions occur. Exception will propagate back to the caller. So this is, like calling a method, call a method and you can get the response back. You call this and if it errors, the caller will get notified of the error. So that's pretty cool. You get that real-time information back about whether that message has been consumed and processed. So containers, to configure mediators using a container, use the add mediator. So we've already done that, but what's happening here? So if anybody noticed, I think we just skipped forward an hour. The kids needed help with lunch, so right, had to feed them apparently. So where was I up to? Yeah, I did the order, but the submit orders consumers complaining still. Looks like we've not got that. So if I look at this example, submit orders consumer. Did I just miss it? No. So they give an example, but they haven't provided the submit orders consumer. So that won't run. Okie dokie. So let's just make one up. Copy that. Paste that in, and it was submit orders, and there's a get order status. Need a submit order. I would have thought. Don't like it being underneath like that. If it, so let's have a look at the interfaces that we've got. We've got get order status, and we've got an order status. So submit order. That's just complaining about it being not async. So submit order. Looks like there isn't a submit. GUID, order ID. So that sends a new order. Then create request client. Mediator create requested client. It's just going to get a client to then get the response. And that gets a response which is an order status. So I'm guessing that when we send the submitted order, we have this mediator and we create the request to get order submitted. We get that client back, get order status, then we get the response. The response then is going to be the status. So the consumer here responds with this order status, and then this submit order should return back a submit order, really, I would have thought, possibly. Kind of, for my brain, I need to kind of draw it out. So it's a bit obvious, a bit simple, but with everything, when it's for you're trying to work out something, it looks more complicated than what it really is. All we're doing is sending an order out, submitting an order, and when we do that, we should get an order status back. Just don't understand why there's a client and then a client with a response. So that's going to get the order status and return the status back. So I'm not quite sure what happens here. Now let's see if it just even runs first. Okay, so I've got some errors. Didn't show up. So avoid or init return entry point can't be async. So program 10. Public static async task. It's a bit weird that you can't have an async main, but I suppose you need to be able to call it and get something back. Okay, .NET run. No idea. So get a hello world, and we get an exception. Message not consumed exception. So the message wasn't consumed. So we sent off the message, and for some reason it just wasn't consumed. So let's do a bit of dividing and conquering here. Let's just submit the order and just make life a little bit easier for ourselves by just, restricting this down. So we're only sending one thing out, which is the submit order. And we're basically adding a consumer, and the consumer has got submit order. So if we look at this, submit order consumer, that gets a consumer of get order status. So that's wrong because that's submit order. So submit order consumer should get that. Okay, so I did that. Not much to show for it, to be honest with you. So let's show that our consumer did actually do something. It did actually call. So calling. Oh, fat fingers again. Submit order consumer. Let's look at that context. I've no idea. Like we've got like correlation should have message, yeah. And do we have a order ID? Yeah. Probably gonna have to do toString on that with it being a GUID. Is that gonna work? Let's have a look. So we're going to make a call, and we've made a call to submit order consumer, and the order consumer is then going to raise a response back of order status. So the order status we're going to get back is pending. So if we have a look at this bit here, we're sending, we're going to wait for the response. and we're going to create a mediator to create a request client to get order status. Now that's just a client. That's not going to do anything just yet. And we use that client to get the order status. We'll create a new instance of the order status. We'll call it order ID, order ID. So we're getting the order ID from the response back. Not quite sure why we're doing that, because we should just get that response back. So let's run that. We should see status of pending. So get order status was not consumed because we forgot to undo. Notice I said we because we're in it as a team. If I fail, so do you. Right, okay, so we get an order pending. So what's happened there is we've delegated responsibility to a consumer that's going to consume our message, our get orders, and it also has the ability then to submit an order and get an order. So here at the top here, we're going to submit an order, and this is the order ID that we're interested in. Let's say we want to buy some slippers this time of year. It'd be lovely to have some nice new slippers. So we send an order out, and that is then instantly processed by the consumer. Now, our consumer that deals with this is Submit Orders Consumer, because that's the name of the interface, and this consumer deals with that interface. It consumes it, it processes it, it does something with it. So here we work on it, and we're saying, right, we've been called, and I've been raised. Someone's shouted a message out, and I'm the person responsible for it. So I'm going to call out, and then I'm going to respond with an order status to say that it's pending. And then at the top, what we'll do is we'll create a mediator to create a client. And this client's interested in the get order status. Now, if you remember, that's what came back from our submit order. It's the thing that it raised. So here we're interested in grabbing the data. We actually want the data returned from that response. So we get the response, we cast it, and I don't know why we're doing this, to be honest with you. My guess is that it needs that to actually know which response we want back, because they're independent. If you look, the mediator, that's just a call. So we use that mediator. So I suppose we are using the same mediator, but I would guess that if we didn't have the correct ID, it wouldn't be able to return back the correct response. So let's give that a go. So let's do new or random, let's say. Random order ID. So this is the order that we're going to go ahead with, and I'm going to send it to submit my order. And then I'm going to try and get a response for an order, but the order that I'm going to use is going to be a completely different one. What I'm expecting to see is that we will call the consumer, but we won't get an order status pending back. Yeah. So I was wrong. We did get an order status pending back. So I'm just no idea why. So let's see what's happening with these IDs, shall we? So I'm just going to log these IDs just to get an inclination of what's going on. So I'm going to change it to calling to consuming. I'm going to change the other into producer. And I'm just going to get that as the order ID. That way we know what order ID we submitted and we know what order ID came back. Order status 0 and 1. So response. Oh, what are you doing? Message. Order ID. Okay. Honestly, Gary. Can't even blame that on fat fingers. That's just daft. Right, so let's run. Okay, so we've got the same IDs in, and back. And when we get a response and we pass in this new, it doesn't seem to have any impact whatsoever. But it needs it. Which is really, really bizarre. Because why does it need it if that order ID is not even the order ID that we put in? That's so bizarre. So I don't know if I can actually dive into that. Yeah, I can IntelliSense in. So creates a request and returns a task for the specific response. Great. Just doesn't mean anything. The value to initialize a message. So the first one's the value, then you've got a cancellation token to cancel it mid-flight. And just a timeout. I'm assuming, if you want it to, you've got to deliver expectation. It can't take more than 30 milliseconds. You can put that timeout there to stop things hanging too much. You don't want users waiting for something that's just not going to happen. You can allow things to be cancelled, and then values. And the value to initialize the message. That's just not true. So order status, string temp, yep, temp message, MSG. Let's go VB old school. Temp message equals hello Bob. Let's do temp message. Let's just get that back. I think it's just a constructor to allow us to set some happy defaults within our message. So order status, that, we got the ID, but we actually didn't get our message because it's probably null. Message, yeah. But that's the order status from the response. I'm going to move on because I've just got no idea why you would populate that value when it appears like it's not using it and it appears like it has no impact. get the response from order status. So order status is here. And that's just get order status. So the thing I put that on is order status, which is here. So I'm wondering if you can pass in some happy defaults into this so that it can then be sent back, possibly. So message dot order ID. Message is a submit order, not an order status. The only thing that's an order status is a thing that's responded back here. And here we create a new instance of it. So I just want to have a look at that context and see what's in this context. This might not work. You should debug. Should have it set up. I've been playing about with .NET and just reinstalling and updating, so this might not debug properly. So far, so good. Got call stack coming through. Great. Right, so context. It's a big, isn't it? It's got lots of stuff in it. So a message. So that's just got the order message. I'm just seeing if I can see that constructor, but I don't think I will because it's got nothing to do with it. What I'm wanting to see is where that'll be problem with timeout because of holding. You know, I did this. We got what? Temp. What did I call it? Call it temp message, didn't I? What's going on here? It probably looks like IntelliSense just going a little bit wobbly. So that data is being passed in and we're getting a response, but we're actually telling it values that we want back. But that's not actually what comes back when we look at the response. So I need to research that a little bit more and figure out what the hell they're doing. Let's dive over to the example. So that's the end of it, really. This shows us how we're able to call a system and get a response back. It's like you're calling a simple method. You know, you call a method and you can get data back. This is a way of being able to add items into the queue and get the value back. What I'd be interested to see is how that works when using a RabbitMQ or a different kind of factory, and how you were able to get responses back from consumer when actually really using a messaging engine. At the moment, this is all in memory. Now, I'll correct something again that I've said in a couple of other videos where for me, the end goal is always to have these as separate services. You're going to have a RabbitMQ server cluster of them. You're then going to have a producer that produces a message and a consumer um, hosted somewhere like Azure or AWS or your favorite choice. And that consumer is a lightweight microservice, my opinion, Dockerized, containerized, running on Kubernetes or some other orchestration engine that just sits there and processes the message. And you can have multiple instances of it running. So if one crashes, the other one can still take control and you get load balancing. That's the end goal for a messaging system. However, when you're first starting off and you're first designing a system, you shouldn't think about that type of architecture first because it means you have to start cherry picking which bits and services you actually move out to a microservice architecture. What bits do you actually make a consumer? And once you've made them a consumer and you've got a separate service and you're pushing out, let's say you've done this awesomely and you've got CI/CD using, DevOps or something, or TeamCity or whatever your choice is. Well, you're stuck then. If you've made a mistake and these two things need changing all the time, but you've made them two completely separate services, then it's a nightmare. Especially if two teams are responsible. One's responsible for that and another's responsible for that. You've got phase gates of knowledge transfer, information sharing, getting your sprints lined up. It's a pain in the ass. So I actually fully on board with what they're talking about with, first off, building a monolithic application where you've got all your code in one central place in one big project, but you're using a mediator pattern to separate this responsibility. So when it's time to move this consumer out into its own service, well, you've seen my other videos of how easy that is. All we now need to do is change the producer so that it's actually going to use a proper transit engine like RabbitMQ or something like that. So this is really cool. This mediator was pretty simple. I'll do a bit of research and add to the comments if I can figure out what the um, populating the values are within the get response, and I'll try and work that out. If anybody knows, please drop it in the comments. And once again, like and subscribe, and thank you very much for watching.